Hey, how it's going, guys? In this video, I'm going to give you a walkthrough of my workshop session at PyCon India 2025. So, PyCon India 2025 was scheduled, in Bengaluru, and we just wrapped up, that conference that lasted for 3 days, I think 4 days, including the dev sprint, and my session was on AI agents in action. It was a 3 hours workshop session that I took it with my fellow co-speaker. I'm going to talk about it. So if you look at here on my screen, this is a slide that we have here, AI agents in action. It was a hands-on workshop session where Kalyan and myself, both speakers, we kind of took this workshop for more than 100 people in our track, by the way, more than 1,500 people in this entire conference, right? And if you don't know PyCon here, this is how PyCon website looks like right now. And if you look at this PyCon India 2025 Python conference, one of the most premium Python conferences across the globe, right? That has been happening, since so many years. And if you look at it was from 12th to 15th September, so it basically ended today while I'm recording this video, and it was in Bengaluru. And our workshop location was this particular college that you see, St. Francis. And then at Nimhans Convention Center, the conferences ran it for over 2 days, and at a dev sprint we had that as a at an engineering college, right? Some keynote speakers, and if you go to programs schedule, if you click on workshop, this is where our session was, right? In room 2 or track 2, agents in action, from concepts to live agent demos. Kalyan Prasad and Sonu Kumar, that's what my name is, by the way. And this is what we're gonna do here, right? In this video, I'm gonna walk you through that what I did there in the workshop, because I'm not sure if recordings will be available. That's why I'm recording this video for all of you, to understand AI agents in layman terms, right? Agenda, of this video or that session, works or whatever, was to, of course, talk about agents 101. It means that simple definitions, concepts, types of agents, differences like agents and agentic AI, different terminologies have been used interchangeably, in the recent times. Uh, orchestration design patterns, prompts, techniques, router, context switching, single agent, multi-agent, the state, the memories, and everything that basically helps you build production grade AI agents, right? Or agentic AI solutions. We're gonna look at some demos and some frameworks to comprehensions, when to use what kind of frameworks that we have, right? Then we're gonna talk about MCP, Model Context Protocol, AgentOps, the observability and governance, and such topics. uh, Outcomes of this video or this workshop session will be, you'll get a fair idea of AI agents and agentic AI fundamentals. You'll understand different design patterns, a single agent, multi-agent. You'll also do end-to-end multi-agent app. You'll wire agents to real tool via MCP, observability, eval, safety, and future of agentic AI. Meanwhile, this is happening. I'll just run off my Streamlit Cloud here. I'm going to run up my app here, right? Let me do that quickly. This one, yeah. All right, I have to wake up this app, and perfect. So this has been there. You can walk through it later. Let me just come back on my slide here. So I was taking this session with one of my community friend, Kalyan Prasad, that you see it over here. He has been in this industry for last 15 odd year, right? He's a mentor, he's data scientist, data science managers, and so on and so forth. And this is my profile. You can see some details. You can find it out later. Not important. Agents 101, definition, scope, mental models. What is an AI agent, right? So if you look at here on the slide, that what we have, it's a system that selects actions to achieve goals within a boundary. So boundary is important. When you're working with AI agents, there has to be a boundary that you have to define. If you don't set a boundary, then you might get into trouble, right? When I say you might get into trouble, it means that you might see a lot of token cost, agents not behaving well, they start drifting, they're not getting right responses, and so on and so forth, right? So it has to be within a boundary, and where you set some instructions, and agent uses LLMs, multimodal models, or AI models, and they use just some kind of tools, prompts, and you can also have memories for a wider context. So that's what a LLM is. Basically, it has a purpose. Your agent has to have a purpose when you're building agent solutions, LLM powered agents. The reason we have LLM powered agents here because agent is not a new thing. We have seen RPA based agents, statistics based agents, right? We have seen automations through agents, rule based agents. Now we've been talking about LLM powered agents because LLMs are so good. They can reason well, they can follow your instructions better, and so on and so forth, right? So these agents can plan, they have a purpose, they can call different APIs and tools, custom tools, already built tools, and whatnot. And they can basically perform your task and give some kind of output. That's what they do. And if you look at your AI agent for agentic AI, this is a very important slide for you to understand. And before we go into it, I will give this link in description. This called AI Agents in Action, this GitHub repository, where you can find out this particular presentation and all the notebook that I'm going to cover. So it's not only a PPT presentation. I'm going to run this step by step, all the notebook, give you a walkthrough of how it works and whatnot, right? This is important for you to understand. And of course, this is my LinkedIn account that you see here. Sonu Kumar, my two last posts were on PyCon India. It was an amazing experience, guys. And if you're a Python developer and if you are also interested in AI, machine learning, data science, etc., you make sure that you visit this event, right? This is an amazing event, right? A conference, and it happens in different cities in India, mostly Bengaluru. We also did that in Hyderabad in last few years, right? You can see a lot of goodies and a lot of things that we get here. You can see some good things around Bengaluru. It was an amazing experience. And also, this is the workshop track. So if you look at this is our track. He was my co-speaker or session that we took it together, and this was our track. You can see a house full room, more than 100 people almost, and in this room. This is how we're taking it. You can find out everything over here, right, about this. I'm going to talk about this thingy. So make sure that when next PyCon is happening, you attend that because it's very important for you to network and learn from people. It's not only about writing some programs and you know you you say that okay, I'm a developer. Of course you are, but it's beyond that, right? Try to make open source contributions. Try to participate in these events and do networking, mentor, and etc. Right? Very important. Let's come back here. Uh, AI agents and agentic AI. AI agents is basically more instructions based, where you have set some instructions and it follows the instructions in a very confined manner, where it does not has a lot of autonomy with it. Agentic AI is more of a broader paradigm that you see. It's a more of a broader scenario where it has more autonomy, right? So it can make autonomous decisions by its own. It requires very less human intervention. Okay, even with the limited set of instructions, it can learn from whatever is happening within that boundary that we talked about, and it can learn over a period of time, and it can improve in a multi-agent setup. Like let's say in an agentic AI workflow, there are 5 agents, so these agents can learn from each other and they can learn and they can improve. Okay, so you don't need a lot of human intervention in that. They have more autonomy with them. They can reason well, they can plan well, they can execute well, etc. So basically they have a better reflection mechanism built within it. That's what it is. And nowadays people are talking about agentic AI because we are mostly talking about multi-agent solutions where they have more reflections, where they can learn from each other. They're based on reinforcement learnings now and etc. I'm going to talk about that in a little bit. So this is a difference. There's a research paper on that. I would recommend that you read that research paper. You can see it over here. My bad. Yeah, same thing actually. You can read this paper here, AI agent versus agentic AI. You can see the image that we have taken it from here. A conceptual taxonomy, applications and challenges. It's from Cornell. Let us see, Cornell University in the back in the States. Now, Let's come back here, guys, right? I'm going to talk about some use cases and industry signals for you to understand. One of the most important case studies that I have seen in recent times when it comes to the ROI or success of an agentic workflow is from Uber case study. So Uber has shown a case study, of course, available on YouTube, where they have saved more than 21,000 developers hours. So it's a more of a productivity gain for them. Uber, they kind of get more than 33 million trips globally in more than 15,000 cities. So it's a very big company, very big organization that we all know, right? And they kind of keep on releasing internally they keep on releasing a lot of features, and they have to do testing for that. So they started using LangGraph and LangChain based agents, where that was doing automatic testing for them. And of course, they had other chatbots, internal chatbots built on LangGraph and LangChain. So have a look at that how they built it, and this they're helping the developers to save these many hours, right? There are a lot of other use cases, AI agents, right? Or let's say agentic AI, if you talk about a more broader sense, or generative AI on a higher subset, have revolutionized almost all the industries, right? There is no industry where we cannot bring this technology if there's a good use case. In healthcare, pharmaceutical, defense, manufacturing, retail, marketing, supply chain, and whatnot. Everywhere you see there's a way we can bring this to solve some complex problems or even common problems. By the way, generic, we can also do that. So this slide is important: adoption and market stats. Now, this gives you two narrative here. One narrative is that a lot of companies and enterprises, and also, of course, universities from an academia standpoint, most of the organizations now they are implementing or they're trying to implement Gen AI, or they have some kind of AI initiatives. Of course, because the pressure is coming from the clients, investors, and the competitors. Uh, if you look at some of the reports, right, by 2026, 80% of enterprises will test or deploy Gen AI apps. That's what Gartner says. But Gartner also says, on the other hand, that over 40% of agentic AI projects will be cancelled by end of 2027. An MIT report, you can see 95% of generative AI pilots at companies are failing. Of course, this report, I'm not a big fan of this MIT report because I saw there are some loopholes in that. But the Gartner one is correct because of the lot of issues on the risk management and the ops layer, which are missing in the agentic AI projects within enterprises because leaders are not capable to make such decisions. So there are two narratives here. One is that almost more than, I think, 90% of the organizations they want to do something in the AI, but only few of those projects or initiatives have shown a large scale transformation or a large scale where we have seen large scale ROI coming up, kind of any kind of things, even innovation deliveries and whatnot. I haven't seen any such things, to be honest. Okay, so it's same time it's risky also, so keep that in mind. Now, I want to talk about design patterns and orchestration, that how to build an AI agent. What are the minimal thing that is required to build an AI agent? So goal has to be there. You can see the first thing, define goal. You clearly define the objective and scope of your AI agent. What tasks should it accomplish? What are the success criteria? And then you choose LLM, because we're talking about LLM powered agents, not rule based or statistics based or RPA based agents. Here we are talking about LLM powered agents. So make sure you have an LLM. Okay, that can be LLM, that can be chat based, responses API based, and whatnot, right? You can have some tools. Tools can be either already built tools which are available in open source or also through third-party APIs, or you can also build your own tools, like let's say define in Python functions and wrap that around, or even MCP servers or whatever, and wrap that around to use within an agentic workflow as a tool. Memory planner is important because context is everything, right? That's what we are saying. We talk about context engineering. I'm going to talk about that in a little bit when I'm showing you some notebooks we're going to run. Test and iterate and deploy, right? That's what we do here. You can see, and there are different ways you can build it. You can build agents in pure Python, or you can build agents via N8N, Parentic AI, LangGraph, or Agent SDKs. And Haystack or Strands Agent or Azure AI Foundry. You also have AI Studio. You have AutoGen. You have hundreds of other frameworks to build AI agents. Now, there are core agent patterns which you should understand. The simplest is React, reason, act, observe. Okay, so you can see reason plus act with tool calling, the most simplest, most easiest, most common uh, orchestration, not orchestration, agent patterns. Okay, then we have plan and execute, where we have some global plan and atomic tool steps. So tool steps will be defined subsequently, and there will be a global planner who will plan it, and then they will execute with using the tools available. We have router gateway, so capabilities based dispatch that you see, whatever capabilities one agent might have in a multi-agent scenario, so that will be routed. And for that router, now we have a lot of orchestrators available that to route, or routers or orchestrators to do that. Reflection, I talked about it, right? Self-critic and improve answers automatically. So, you know, in a confined boundaries, agents can kind of improve it like by themselves from learning from the weights and biases. And it's correct, weights and biases, yes. I have a research paper on that, read about it, that how agents can be improved, with the reinforcement learning techniques, like, we know alignment techniques like DPO, PPO, and whatnot, that can be used also to improve the performances of AI agents within an agentic workflow. So I'll give that link, have a look. And task graph, LangGraph based. Let's have a look at React agent here. So if you look at here what I'm doing, and this is the notebook. So this notebook is available. It's called Pure Python. This is the notebook that you see, Pure Python React agent. And it's built in pure Python. We are not using any framework here. So what we're going to do in this notebook, if you look at in this notebook, it says this notebook demonstrates a single agent AI system that uses the React pattern, reason, and act. The agent can intelligently decide when to search the web plus when to use its built-in knowledge. Key features: intelligent search based on temporal keywords. I'm going to talk about that in a little bit. Integrations with Gemini Flash for reasoning. Web search via Super API. So if you don't know Super is amazing, right? Super Dev. If you look at Super Dev, this is what Super Dev is: world's fastest and cheapest Google search API. React pattern, based on reason and act. Here I am using Google Generative AI, that is C, in this, and request to use the server, because we're gonna use through and like the request module in Python through HTTP, and then you can see Google Generative AI here. We're gonna use Gemini model through it. Here I'm configuring the keys. So you can see we have Gemini API key, Super API key is saved here in my environment. So you can see API key configured successfully. Now for this, I have a pattern recognition technique. That's, if you look at here, search trigger intelligence module. It says this is a core decision making component that automatically identifies when a wave search is necessary using pattern recognition. You should not see, you can still bring an LLM layer here based on your task or query. It will first classify whether it should call the web search, or it should just go to the base knowledge of the model or the LLM. But here I have a temporal keyword based pattern recognition. So you can see I have a class search trigger intelligence. It says the search trigger intelligence module is the system's core decision making component. It automatically identifies when a web search is necessary using pattern recognition rather than simple keyword matching. So you can see time sensitive keywords that indicate need for current information, like immediate, recent, trending, temporal markers, like year, next year, past years, news indicators, current info topics, so on and so forth, that you can find it out here. Conference, where, what is the latest, tell me about this, and just run it. So you can see we have a search trigger intelligence module that has been loaded. Now we're going to use Super API. So this is coming from Super. You can see we are using a web search tool, and very modular code we have. You can see it's wrapped in a class web search tool. It says web search functionality using Super API, and you can see it over here, diff init. And this, basically, this is a URL endpoint, google.super.dev/search, and you can find out define search. You can look at this. It gives you 5 top results. Perform web search using Super. We are sending the payload for json.dumps query number of results. Here are the headers, and it gives you the response. And here we're going to format the result because it gives you a result in a different format. You can see it says wave search tool loaded. Now we're gonna just do the Gemini LLM integration. So we are using Gemini 2.0 Flash for this particular notebook. No any particular region, you can go with 2.5 Pro also, or 2.0 Pro also. Now here is our React agent that you see. Now it's the main React agent that combines reasoning and action capabilities using the React pattern. So in React, we have reason that analyze the query and decide what action to take. Then we have act, execute the action, search wave or use knowledge, and observe, process the result, and generate final responses. That's how it works. You can see we have a function, the init function. Then we have the region here. It regions it. You can see the reasoning here, act here, and then here we have observe and respond. Okay, you can customize this fully. You can see it says pure React agent class loaded. Here you can initialize and test. Here I'm initializing that pure React agent. And then like, let's say, uh, here let's write a fast API backend for, you know, for fast API write a fast API for, for inferencing an ML model saved via pickle or joblib, something like this. Let's see if it can do it, right? And if you see this, right, this is a technical question. Here I've been asking write a fast API, and here I'm going to highlight a few things which is important for you to understand, that sometimes uh, the temporal uh, keyword based that thingy that we were showing, it might also backfire. It's not always a good practice to do that. So I just want to highlight that. It's going to take a little bit of time to do that, so let's just you can see it started here, by the way. Okay, now it's done. So if you look at this, right, it says starting React process. You can see write a fast API for inferencing an ML model saved via Pickle or JobLib using built-in knowledge, no search needed, and decision is direct response. Because for this particular question, you don't have to go and search on web, because LLM is smart enough to kind of generate an answer for this. That's why it's very important to have that pattern recognition module built in it. Otherwise, sometimes LLM might get confused, right? Because LLM has a tendency of hallucination. So you can see here, we got a very fantastic output, from this thingy here from agents. So I really liked it here actually. It gives you a very detailed output. Okay. And you can see, access the API, Swagger, and everything is over here. Fantastic, right? Amazing answer. Now let's say go to the next question here. And where is PyCon 2025 India happening? And tell me more. You can see now it's doing web search, and this is the same thing I'm talking, because this session that we are doing right now is, of course, is after PyCon India 2025 in Bengaluru. And you can see, where is PyCon 2025 India happening? And tell me more. And you can see the answer says search triggered by temporal keyword, the temporal markers. And decision is web search, acting web search, observing results and generating response. And this is the final response that you see. You can see it over here in Bengaluru. We did that, right? Fantastic. And one more question: what is the latest development in AI? Again, it's going to do web search, because the word recent is there, right? Latest development. And see, latest. Okay, let's that's very interesting. I want to show you something here, right? You can see latest, recent. It's not only very hard coded keywords, it automatically inference the pattern, right, in that module, and it finds out for you. So you can see defect detection. A new universal AI detector boasts 90% accuracy in identify defect videos from Crescendo AI. So this is amazing, right? I really like this here. Let me just get this output for myself. I liked it really. I'm just going to put that Intelinger MD here for some later references. I want to read that actually. So I want to read that for myself. Okay, going back here. So this is summary of React Agent, Region Act Observe. And it's a pure Python demonstration. We didn't use any framework. Of course, there is no state or memory, but we can also do that. Very intelligent decision making through pattern recognition module to decide when web search is needed. React pattern implements region and act observe cycle. Multimodal responses can both do search and built-in knowledge. Temporal awareness is there that recognizes the time-sensitive queries. Topic classification that identifies domains that require real-time information. Fantastic, right? So this notebook is here. You can of course go through and get that notebook for yourself. Let's come back. Now, I already have a video on this, very detailed, called Core Orchestration's Agent Pattern. So first one is sequential orchestration. So if you look at on the right-hand side, here we have process.sequential. Nowadays, we have an orchestrator, right, which orchestrates multiple agents. Agent one, like for example, let me just show you it here. So let's say I have 5 agents, right? Let me just show that here. So let's say this is my agent one, and this is my agent two, and this is my agent three, and this is my agent 4. So, and there's a task. Here you have a task that these agents has to do. How do they coordinate with each other, guys, right? For that, you need something, to do that. And that's where, we have orchestrator. So you need orchestration. So we have an orchestrator. Now the task goes into it. Orchestrator decide, to route to this, route to this, route to this, or how to work together, how to sync, and everything, right? So this orchestrator that you see is basically, it's not that easy. It's not that simple or straightforward. It has to be very based on use cases and whatnot. Uh, Here, if you look at this, we have multiple. We have sequential orchestration that Crew AI has something called process.sequential. Now, what happens in sequential? Output of one agent become the input of the next agent. And you can see it's in the sequence manner. If you look at this agent A, agent B, agent C. Let me show you that quickly, right? Just to quickly show it on here only itself. Okay, so if I open here, I think I have hierarchical. I want to highlight that also hierarchy thing. So I'll just get rid of all the login thing. Yeah, I think this will be fine. Let's go back. Then we have a map reduce. Map reduce is very intuitive because this has been used in summarization use cases. Let's say you have a document, a very big document of a patient, last 20 years of patient history records, and now you want to give your agent to summarize, based on different categories, like what kind of all medications over 20 years, all surgeries, all uh, allergies and different things. So what you do here, you basically give a specialist agent. Okay, they basically look at these categories and create individual summaries, and then within you there is a reducer basically that reads all this summary and create a final summary. So it's called map reduce. Okay, it's the straightforward. The use case is summarization when you're working with it. It's very helpful in RAG also sometimes. Then we have consensus mode. Now consensus is very interesting because what happens is there will be a voter. So it based on majority vote. Okay, so the majority vote is there. So let's say all agents have their own outputs. There will be voting, and based on the voting will be decided whose output is, or it can be a collective sum also of the output and can get a new output to be generated. That's called consensus mode. Okay, now we have layered orchestration that is more hierarchical based on hierarchy. So if you look at this in this notebook here, we have process.hierarchical, in this. So Crew AI provides process.hierarchical, process.sequential, and so on and so forth. So this is the Crew AI notebook that you see here. We have an agent. So we have 4 agent: data analyst agent, trading strategy agent, execution agent, risk management agent, and we have given them a very specific role and a goal. The goal that I talked about, each agents have their own goal that you can see. They have their own role that you can see, the backstory and everything, what kind of tool they can access, right? So the task has been given to them, what task they have to perform, all of these agent, and then we use process.hierarchical, for this particular orchestration design pattern that you see, layered orchestration. We have producer reviewer model, very similar to what consensus is, but in a bit different. Like there will be an worker agent, there will be producer, there will be reviewer agent, and the final output will be through reviewer basically. So this is there. I will show you that I already have a video on that. So I want to show you which video to watch. You have to go and watch this video. It's called multi-agent. you have to watch this video, guys, called multi-agent system design. Here I have created a streamlit application that you see. It's called multi-agent orchestration playground, sequential map reduce hierarchical consensus and producer reviewer. So that's what it is. So this is the agent pattern. Okay, it's very important. We ask in interviews also a lot lately. Then we are designing a simple agent, LangGraph React agent with memory, right? Here React you already know, I shown you reason act, but then we're gonna do that with LangGraph because LangGraph is one of the most used orchestration framework, and LangGraph is from LangChain, right? And LangGraph is good because it is stateful. You can manage state really well. It's easier to work with memories, and when you have a lot of context, it's easier to manage. But there's a learning curve. It's difficult to learn. But we're gonna show you some of the LangGraph thingy. Okay, over here, let's just go back to this notebook. Let's close this. Uh, and I'm gonna open this to here actually. Interesting stuff, guys. Just gonna close up or I'll keep this for now. I'll close my YouTube. I'll just close this. This is something we can walk through it. I will just want to show that later. I think this is also done. I shown you the PyCon thing, and this is fine. Okay, cool. Okay. Okay, let's just run this because this is what I want to run. So I'll just connect here. LangGraph React agent with memory, right? That's what our slide is also talking about. LangGraph is based more on graph-based structures that you see. You'll have an start and an end thing, and then in between we have multiple nodes, that can access. They can access tools, they can access a memory saver, databases, and whatnot, right? So I'm just gonna walk you through this. So memory is important. So here we're going to talk a little bit about memory. Okay, LangGraph has a memory saver function. Okay, uh, it's basically LangGraph. You can manage the state through message state. Okay, so we're going to look at that. You can persist the memory using checkpoint mechanism. So checkpoint mechanism is available within LangGraph. Okay, and there's something called scratch pad also. So scratch pad is used basically as a note taker, like how we take notes, right? Where agent also takes notes, through scratch pad within LangGraph, and they can also forget it, if the context becomes bigger. Okay, that's a trick actually. Okay, that's a tricky thing. And then we're going to look at tool integrations for some weather queries, conditional routing. So routing that I talked about, conditional routing between reasoning and action, and then multi-turn conversation support, right? So let me just run this thingy here again. Google Generative AI we are using for Gemini model, LangGraph we are using for as an orchestration framework, LangChain for some supporting utilities, and LangChain core for like vector database is required and whatnot, like ChromaDB and whatever is required. You'll see. Here we set up the key. You can see my Gemini key is set up. And you can see here I'm going to use Gemini model in this class. Very simple, uh, like templates, for Gemini that we have. And Gemini with tools we have. You can see it over here. Process tool result provide final answer. So this is a very detailed class. You can go through it. And if you see, it says Gemini model initialized successfully. Now, tool integration and reasoning action mechanisms that you see, it says define the weather tool. Here we have a very simple weather tool. It's not actually calling any APIs, but you can bring your own API driven like open weather map or something to do it. Here I have a very simple function just to show you, and I have wrapped that through a decorator called tool, and you can see define weather tool. Okay, so let's define this. And this is a basic LangGraph workflow implementation that I'm going to show you. You can see I've commented it also for, of course, the audience. I commented it so they can go through it. You can see it says, we build a basic graph structure that only contains model calls to demonstrate the basic working principle of LangGraph. And you can see basic LangGraph workflow implementation. As I said, right, it's a graph based, so you can have multiple nodes. Here we have a single node that you can see. It says build a single node graph structure. We are using messages state because in messages state we can manage the state for state management. So that is there. You will not find this thing by default in frameworks like LangChain and AutoGen and whatnot. That's why LangGraph is better because the agents have the state available while this entire workflow of one cycle. Okay, or multiple cycles also if the session is active. Okay, you can see workflow.add node. We have something called my bot. Okay, that name of that bot, and then we compile and run the workflow. So here I have a dummy question that hi, hello, how are you? So basic test result says, hi, I'm doing well. Thank you for asking. How are you doing today? We have that. Now React agent node construction. Now after defining a custom tool, we integrate it with the LLM and implement a calling mechanism with a LangGraph node. So let me just do that. So you can see here I'm using a React agent node construction and tool registrations and binding it. So you can see it over here, tools, weather tool, and I'm just binding it over here, bind tools function and tool, defining a LangGraph node that is tool aware. Now the tool has been binded, right? But then we have to have a node for that. So that's what we are doing here. Now, this is a React graph architecture design. Okay, so basically we're going to bring everything together. The process connection between agent and tool is implemented through the LangGraph graph architecture, structure, whatever you call it, which includes routing logic and state management. So you can see it over here. We have a router function of workflow, initialize the tool node that we defined, define React here, the entire React pattern that you know, compile, and our architecture is ready. And here we're going to test that. So I'm asking what is the weather in Bangalore? And you can see it says the temperature is 25 degrees Celsius and cloudy. Because we have defined it above. But that's not the problem. That's not the main agenda of this video. Agenda is about memories and stuff, right? If you look at here, it also has streaming output. It gives you the streaming output you can see. And now the memory system integration. As I told you about memory saver component. So LangGraph, basically if you read this line, it says for practical multi-turn dialogue applications, memory is an essential technique. Because if you go to some chatbot applications like ChatGPT, if you keep on asking questions, it remembers the previous outputs or whatever you have discussed with it, right? So if you see here, it says LangGraph provides built-in memory support through a checkpointing mechanism using a memory saver component. Now this is what I do here. Memory saver, memory system integrations, memory saver that you see. Here I'm building memory enhanced workflow that you see it over here. Workflow add node and then add as and then compile the workflow with memory support. So let's integrate the memory within it and then we're going to test it out. So I'm asking what is the weather in New Delhi? And if you look at this first query, New Delhi, what is weather in New Delhi? So it says, I will check the weather for you. Tool calls. This is the tool call. What is the weather in New Delhi? You can see the temperature is 45 degrees Celsius and sunny, and it gives you the AI message. The weather in New Delhi is sunny and the temperature is 45 degrees Celsius. So this is the AI message. Now I perform a secondary query in different region. And you can see the temperature is 42 degrees Celsius and partly cloudy. This is the final answer is this. Now let's test the system's memory capabilities. And which is correct. So if you look at here, I'm asking in which city the temperature was 45 degree. And now if you look at it, it says the temperature was 45 degrees Celsius is New Delhi. So it figured it out because this is what the temperature in New Delhi was that you see. Fantastic, right? So you can test the, I probably don't need this one actually. I'll just get rid of it. So this is summary that we saw. You can see a message state. It's the core state model using the type dictionary structure. It's a type dict structure, data structure that we know. Node system is like abstract callable units into independent graph nodes. We have transition logics between the nodes like through routing, provides dynamic tool execution capability, and then uses message state for conversation history. So this is about a LangGraph thing that I wanted to show you. Okay, this is what we discussed. Now, memory and state design, okay, because there are different types of memory. You cannot again use a generic memories for all the use cases. For summarization, you have to use summarization memory, sequential memory. If you're building RAG-based agentic AI systems, you can use retrieval memory and etc. I have a video again on my channel. I again closed it, but I'll show you quickly. You can see I created this video recently. Where did it go? Here. It's called AI Agent Memory. I'll give the link in description. And this is also deployed for everyone. But you just have to bring your own API keys. If you bring your own API keys, you'll be able to access this playground where very layman terms you'll be able to play with this. And you can see it's called AI agent memory design and optimization playground, where I have explained what kind of memory and when to use it. So please have a look at this video for you. Now, it's not that complex. Like, let's say if we talk about hierarchical, because here I shown you the hierarchy thing, right? Process.hierarchical. Then you have to use hierarchical memory. You can see it's a multi-layered memory, right, for each agents in your workflow in hierarchy. You have retrieval for vector similarity based memories, graph memories, compression memory, and there are trade-offs. Some might take more tokens, some might take less time, and so on and so forth. So this is important, the memory thing. So have a look at that. Multi-agent system and single agent system. See, it's a very debatable topic. A lot of people nowadays are having multiple agents. So first of all, it doesn't work like that. Okay. Uh, you might be just wasting your tokens and latency issues, and there might not be a need of having multiple agents to solve a lot of use cases. So this is how you decide it based on 4 different steps or pillars. First is define the task. Single end-to-end workflow. Like, let's say the task is very simple, lean towards single agent with enough context. You can do context engineering. Context now is everything. Your prompt, your whatever you are saving in memory, inputs, outputs, and everything becomes a context. Uh, Naturally modular multi-stage workflow. Like, let's say if you have different uh, if it's a complex use case where you will have a need of, like, let's say specific agents which are having a specific tools access, because in enterprises not all agent might access all the data repositories or sources also. So then you might need multi-agent architecture there, right? Now, context needs. If task fits inside one model's context window, like with retrieval tools or compressions, and nowadays a lot of LLMs have higher context windows, so that you can fit a lot of information within the prompt itself, like Gemini's and whatnot. They have 10 million context window. If this is the case, you might just go ahead with a single agent. Now, if task requires different knowledge domains or very large persistent state, then you consider multi-agent, but only if boundaries are clean. As I always say, guys, if you're working with AI agents, your boundaries has to be very clear. You should know, what kind of boundaries you have to define. Okay. Now, risks and control. If there is high need for governance and audit trails or checkpoints, so multi-agent but with humans in loop. If low tolerance for fragility, high demand for reliability, then single agent. Okay. Banks or healthcare may want multi-agent checkpoints even if slower. Okay, so that's in the mind. Now, communication overhead. Of course, communication overhead will be more in a multi-agent. Okay, if modular communication is simple, and one agent just summarizes talks. So it has to be based on this framework. A very simple framework I created to explain the audience, but you can again deep dive into all of these individual steps. I've shown you these already. You can go through it. There are a lot of other notebooks that I didn't show. Okay, like we have LangGraph React. I saw memory in LangGraph. Memory in LangGraph. We're going to talk about very detailed memory techniques, like Scratchpad. I was saying, right? A session scoped place, and LangGraph provides. There's a lot of things that you see it over here. Just go through it, checkpointing in memory, threaded memory, how it works, and everything. You will be able to grasp it. Not there's nothing rocket science that you can't understand. So you can also create agents without writing code. So there are different ways you can do it. There are different platforms or frameworks available. Make.com is available. N10 is an open source, of course, framework or platform to build no code AI agent, guys, or automation workflows. And I have a lot of N10 agent built here, more than 150 that you see. It's available. I'll give the link in description. Check it out. For for workflow like this, if you look at this right here, we have a LinkedIn auto poster. I don't know if this works. This is very old actually. Okay, so you have to bring your own API keys. Okay, hopefully it should work. Okay, so what it does, right? It basically brings, maybe last one might give an error. Yes, HTTP request. Stability AI, because I have lost my credit. So that is a problem. But what it does, and this is interesting, this is of course for credits, I know. Yeah, you can bring your own credits and do that. It's basically gonna post on your LinkedIn page. So I have a LinkedIn page, AI Anytime, and I have asked this agent to post on AI and quantum computing. So you can see this is the post that it generated, by the way. Looks good actually, right? uh, and then it has an LLM chain that creates a headline for that image thing, and then image is passed here. So it basically creates automatic post and post also on your LinkedIn. Okay, this is N18. N18 is basically also available through cloud, and also you can self-host it within your own infrastructure through Docker containers. So you can also do no code agent based automation. I have a lot of videos and a lot of workflows are available. Just go and use that for your purpose. Now, frameworks tour, as I said, there are different frameworks when to use what, right? Crew AI, its primary use case is, if you're just starting out in your agentic journey or career or whatever I call it, AI career right now, and you're learning AI agents. Crew AI is a good thing, but first learn the pure Python thing that I shown you here. Pure Python, you should first implement everything in pure Python without any framework. And then you move into Crew AI because Crew AI is very easy to use. You can see less low level controls, adds abstraction overhead that you see over here. LangGraph is more complex. If there's a more complex use cases, is a requirement of stateful memory management, and also it's based on directed acyclic graphs. It's called DAGs, right? So you can use LangGraph, but that will require learning curve. You have to learn that. OpenAI Agent SDK works really good with OpenAI models, right? So there is a vendor lock-in problem. Let's say if the models are down from OpenAI, and then your agentic workflow will not work because you are using such models. So it's difficult to migrate. Fast agent development, they have something called handoffs, where similar to delegations, by the way, delegate. Okay. Parentic AI is also fantastic, which is more really based on more structured and validated outputs. Of course, like how we know Parentic, what it does, it's a data structure and validation library. So Parentic AI also does a very similar thing when it comes to building agents. Very strong typing, schema validations, reliable integrations, and whatnot. Uh, it has its own cons actually. It's very extra schema design. So it's more programmatical. If you're really good in Python, then you can go with Parentic AI. Now, MCP is I already have detailed videos on MCP, guys. I have a playlist on MCP, but very quickly, right, for the audience that's watching this video, uh, MCP is important. Let's say you are working in an IT company, and your manager comes to you and says that you got a big project, and the client is asking to connect with 100 tools within their company, starting from Jira, Confluence, Stripe, Microsoft Teams, Outlooks, and whatnot. Then the guy will think, because then if there's no MCP, then the guy has to create separate APIs and build tools, right, to give it to agent, so agent can pull the data in and of course performs different types of tasks. So MCP came in picture. Here is a unified format, right, where basically, you can, it's very unified, so single, right? So you can connect with different tools with just by using that MCP server as a JSON file or JSON config. Of course, you have to integrate your API keys and whatnot to use it. That's what MCP does. By the way, I have a very detailed video. Have a look at MCP. You can see what and why. It's an open protocol based on JSON RPC 2.0. Okay, if you know gRPC by Google, right? So it's based on uh, that principle. LLM apps connect to remote MCP servers at runtime. So also, if MCP has security issues, but now it's better. So it runs on runtime. So there's no need of like any kind of before runtime doing anything. Uh, Portability, same MCP servers across different frameworks, different applications. You can use it. Like the same MCP servers can be used on LangGraph and can be used on Crew AI, right? Real time, OpenAI real time supports remote MCP servers. Security is very tighter if you compare that with HTTP tools. So it has its own differences. Now, AgentOps. See, so far we talked about building agents, trying out agents, multi-single memories state, but observability, like where how to kind of look at or track the agents that we are building in a production setting, right? That's what we're gonna look at here. So agentic AI governance is very important. A lot of AI agent project fails. That's what Gartner said, right? The report that I shown you in the beginning, that 40% of the AI projects will be cancelled by 2027, agentic AI projects rather. And there are issues with that because people don't monitor their workflow. They just let it work in the production. So there should be a FinOps mechanism first of all when it comes to large scale AI initiatives within enterprises, because managers or the finance team will have a very tiny token budget for the team. They'll say, okay, you only use $5,000 for this project. It's sometimes difficult to do that. So you should have a FinOps layer where you can model the real task size. You can find out how much it's going to cost. In worst case scenario, what happens if the model doesn't listen to instructions and everything, right? So that there should be a FinOps for or unit economics for your AI agents project. No memory architecture. In my experience, 99% of the project fails because there is no memory architecture or memory system in place for agentic AI workflows. State is lost, answer turns circular, right? And cost explodes. Uh, yeah, the manager say, okay, we're gonna use the Redis letter, but that Redis letter never comes. Blind spot evaluation. You don't notice drift. Even agents drift, guys. It starts hallucinating. Trust me. When the context becomes wider, because context is a tricky game. So you have to look at the prompt bleeding, the notice drift, cost spikes until users scream, right? So that is important. No golden data sets, no live quality dashboards, zero alerting. That's very important. I want to show you probably AgentOps here. AgentOps is one of the tools that you can use it. There are other tools. I'll show you here. And this is how it looks like. Let's say I have a crew. This is based on Crew AI. You can get all the dashboarding here. You can see the duration it took, the total cost it costed me, the number of LLM calls, total tokens, and you can find out agents, tasks, and output. You can see it over here, terminal logs and whatnot here. So this is what it is. And yeah, exactly. And then cargo cult architecture. Leaders at the enterprises still using very old slides that they read on McKinsey's websites, and those are not updated because they don't have time to read every day, right? They just listen from whatever they are reading on social media. They don't go deep dive. That's also an issue. So anyway, you need these tools to use it. You can use Opeak. Opeak is an open source, if I'm not wrong, right? Opeak, you can use Opeak GitHub. Just go, yeah. Debug, evaluate, and monitor your LLM applications, RAG systems, and agentic workflows with comprehensive tracing, automated evals, and production-ready dashboards. Because this is how it looks like. Amazing, right? OPIC. It's an open source platform, one of my favorite. I don't know, I'm not going to log in, guys, here. You can see open source LLM evaluation platform. So you're going to use that, log every steps, prompts, tool calls with redaction, PHIs, right? Trace IDs. You can see the trace IDs that I was showing you here. Everything has its own traces. You can see the trace IDs, and this is the ID unique identifications. All these are being logged here, that you can see how agents are thinking, how the outputs are being generated, the terminal logs, everything is logged. Okay, right now it's not running. Okay, so it's not going to show the terminal log. And you can look at the waterfall methods. You can look at the tree view. You can look at the graph view. Graph view is the interesting one. So it's required. Dashboard is important. So build your own dashboard if you have the observability or SRE metrics coming in. Okay. Golden tasks and unit test for tools, offline evals, online evals, auto rollback on regressions. There are different tools like LangFuse and Discard that you can also use it. You can see it over here, right? They have different types of evaluations available. LLM as a judge, experiment management, robust prompt evaluations, and whatnot. Future of agentic AI, guys. Very controversial topics, these guys. I'm not going to talk about AGI or in this video, right? I don't know when will this happen. Different people have different opinions, but there is going to be more autonomy. Agents will become more autonomous. There will be better tools that will be available for agents. There is future of agentic AI. You should learn that, of course. We'll see more digital humans, combination of agents, agents built on blockchain. That's also a future that I see a lot coming up. And risk and governance. So you should do some certifications in the areas of risk and ops and governance, guys, if you want to do that. Long term, yes, area will happen. I don't know when will that happen. so I don't know about it. Here you can reach out to me or my LinkedIn, of course, that is available. You know, this is my LinkedIn. Follow me on LinkedIn, connect, we'll talk. I have a lot of videos just for your information, guys. If you want to master agentic AI, I have this agentic AI toolkit. The only toolkit you need to build agentic AI like a pro. I recommend that to you. I'll give the link in description. Here you will find out 3 months learning roadmap. If you know how, if you want to learn AI agent faster, you'll have your end-to-end workflows. You'll have private repositories, projects access available. You'll have governance toolkit, success frameworks, use case kit, and whatnot. Different types of kits and frameworks will get that into it, right? That's what it is. That's what, guys, I want to do. I know it's a lengthy video, but I wanted to show you what I did in PyCon, my experiences, how good Bangalore was. I loved Bangalore actually. Okay, the event could have been a bit better from an uh, management standpoint, but yeah, nevertheless, I think an amazing event. I met with a lot of people, network. We networked, we talk business, we talk open source, we talk Python, right? If you have any question, thoughts, or feedback, let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. And I'm also going to give you some link of the SaaS project that I've been working on, and these are I'm converting them into some digital assets. If you're interested in buying that, get that link in description on very cheap price. I'm going to add more projects in your future into that. That's all for this video. Thank you so much for watching. See you in the next one.